This video is for both of you. We're talking about inequalities this week. And if you can remember what an inequality is, it just means that it's not always equal to. So inequalities are things that have greater than or equal to, less than or equal to, less than, and greater than. Okay, these are our inequality signs. Everything else is an equation because it's equal to something. But our inequalities always have one of these symbols. Okay, so I want to take a step back and I want to draw a number line and I want to remind you of what you already know. Okay, you already know that on a number line you can graph numbers. Okay, and if we wanted to show x equals -4 on the number line, we would take our pen and we would put a dot on the -4. Okay, but if I want to show x is greater than -3, and I'm choosing another color so you can see what I'm going to do, okay, or I'm going to put greater than or equal to -3. I know that my -3 is here. But this doesn't say x is equal to -3 with a solid dot. It says x is greater than or equal to -3. So it does equal -3, so I get to put my dot there, but I also have to show where it's equal to, or where it's greater than. And so I want to look. I want to say, okay, if I plug in the number 0 for x, and I plug it in here and I say 0 is greater than or equal to -3. Does that work? Is 0 greater than or equal to -3? The answer is yes, which means that I'm going to take my line from my dot and do it in a direction towards that 0. That includes that 0. Now we can also test a point on the other side, and we should. We should say, all right, what if I wanted to test -6? Plug it in. Take that number and plug it in for x. Is -6 greater than or equal to -3? No, it is not. And therefore, we do not shade on this side of the equation. We're not going to shade over here. That's why we put our blue line going to the right, because greater than was in this direction. Okay? So I'm going to do another one and choose another color. I'm going to say x is less than 5. Okay, well, where's 5 on my number line? 5 is right here. It's this line right here. Okay, but I need to show x is less than 5. Well, there's no equal to symbol. It's just a less than symbol. So I can't make a colored in dot because it's not equal to. I have to make an open dot. So I make my open dot on the 5, and now I need to show in which direction x is less than 5. So I'm going to test some points. I'm going to say, all right, 10 is over here. Is 10 less than 5? No, it's not. So therefore, I'm not shading on that side. So let me choose another one. I like 0. I'm going to choose 0 again. And I'm going to plug it in. Is 0 less than 5? Yes, it is. And therefore, I'm going to take my line and I'm going to draw it in this direction and show that x is less than 5 by showing an open circle for the less than and a line going to the left for the x can be all of those values. All of those numbers are less than 5. Okay. Now I'm going to show you what it looks like in an inequality equation form. So we have something like x plus 5 is less than or equal to 10. Okay, now we need to solve it. We have to solve for x. And I treat this equation just like I treat my equal to equations. So in my head, I can just treat this symbol here as an equal to for a little while. I'm going to have to graph it later because it's an inequality, but I'm going to treat it as an equal to for a few minutes. So that means I'm going to solve for x just like I normally would. This says x plus 5. To get the 5 away, I'm going to add the opposite to both sides, and I made a 0 pair here. So I have an x. I keep my symbol, less than or equal to, And now I add 10 plus a negative 5, which is 5. Okay, and this becomes my answer. Okay, but I have to do two things. One, I have to check it always. And two, I need to graph it. So I'm going to draw a number line. I'm going to show that 5 is the number I'm dealing with. I'm going to say, okay, this is a less than or equal to symbol. So since it has this equal to line, I get to put a solid dot. And now I have to show in which direction it gets shaded. So numbers might be 10 on this side and 0 on this side. And you should always show 3 numbers. You should put the number you're graphing in the middle and then choose some numbers on either side of it. Okay, and now check it. If I use 0, is 0 less than or equal to 5? Yes, it is. So I'm going to shade in that direction. Now I'm going to take a look and just check my 10 just in case. So I'm going to say, is 10 less than or equal to 5? No, it's not. So I'm not shading on that side. So this should be a correct picture. But I also need to check my answer. So I want to start with my original problem. X plus 5 is less than or equal to 10. And now I'm going to take my answer of 5 from here, and I'm going to plug it in. Does 5 plus 5 less than or equal to 10? Well, 5 plus 5 is 10, and it is less than or equal to 10 because it's equal to. Okay, so check. I'm done. I did it right. All right, now we're going to do another one. We're going to do x minus 4 is less than 8. Okay, and I need to get my x all alone. So again, I'm going to treat this less than symbol like an equal to sign for a little while. I'm just going to drag it down. Okay, so I'm just going to leave it here, and we'll deal with our side. So in order to get my x all alone, I need to rewrite my equation to say x plus a negative 4 is less than 8. Because I should always rewrite it so that I don't subtract in algebra. Now I'm going to move my negative 4. I want it gone. So I'm going to add the opposite. The opposite of negative 4 is positive 4. And I'm going to add it to both sides. And I'm left with, this makes a 0 pair, so I'm left with the x on this side. I have my less than symbol, and 8 plus 4 is 12. Okay, and so this is the answer that I solved for. But I have to graph it. So I have a 12. I'm going to choose some numbers on either side of it, 13 and 11. Okay, and now I'm going to say, all right, I have to graph it, but there's no equal to. So therefore, I have to have an open circle. And now I have to shade in one direction or the other. So which number is less than 12? So if I plug 11 in here, is 11 less than 12? Yes, it is. So I shade in this direction. But I want to check my 13 just in case. So is 13 less than 12? No, it's not. So I'm not shading. Okay? Now, the trick is that when you check these, if you really want to make them right, this doesn't say x is equal to 11. It says x is less than 12. It doesn't say it's equal to it. And because there's no equal to sign, we can't use this number. We have to use a number that we know x is equal to. And x is equal to every number just less than 12. So 11.99, 11.5, 11.99999, those numbers will work. But 12 won't because there's no equal to sign in this problem right here, since it's just a less than. So I'm going to choose a number that I know x can be. And I'm going to choose a whole number because I don't want to work with fractions. So I'm going to say 11.5 because we know 11.5 is in this shaded region. Actually, I'm just going to say 11. 11 is in this shaded region, and so it is a number that x is equal to. So I'm going to start with my original problem. And now I'm going to plug in that 11. 11 minus 4 is less than 8. Now 11 minus 4 makes 7, and 7 is less than 8. And so we have checked it, and we know that this equation is the correct answer, and this is the correct graph. Okay?